Okay, so thanks everyone for joining today. I'm really excited to be sharing this study with you all. This was a labor of love, 14 months of working on this study with a really great team, some folks at the University of Toronto led by Kelly Doran and some of his research assistants, and also some folks at the City of Toronto, led by Lisa King, who is one of the head planners in the planning department. The project was generously supported by TAF, the Atmospheric Fund, so thank you very much to TAF for supporting this important work. So we had quite a few goals as part of the study, and the first point was really to collect and compare whole building life cycle assessment results for Part-3 buildings in Ontario. If anyone that's not familiar with that language, Part-3 building, that's how large buildings are referred to in the Ontario Building Code. Part-3 and Part-9 are the two main types of buildings. So Part-3 generally is larger than 600 square meters and over 5 units. I believe there's some more intricacies to that I don't remember all off the top of my head, but basically it's large scale construction that we're applying this to. Part-9 is the smaller scale construction that there was another benchmarking study that was done by Chris Magwood at the Endeavour Centre and Sustainable Buildings Canada that worked on that. But this, and we collaborated with them, and our final output primer that I'll touch on has some recommendations for both types of construction, but our specific study was specifically for large Part-9 buildings. So this was the first initiative where we basically went out to industry and asked to collect all of the whole building life cycle assessment reports that had been done in Ontario and put them in one spot, compare them, contrast them, see what the ranges were, and based on that, we wanted to come up with some really interesting suggestions for the industry. And TAF, for anyone that's not familiar, it originally was the Toronto Atmospheric Fund. It was kind of like a shootout of the City of Toronto with a mandate to try to reduce emissions, and it's since grown to be the Atmospheric Fund instead of the Toronto. So now it's regional in scope, and they try to promote emissions reductions across the Greater Toronto area and even all of Ontario rather. So they very much wanted our findings and our suggestions to be applicable widely across Ontario and not just razor focused on Toronto. So we were working with Toronto staff, but with an eye to make recommendations for the whole province. We worked with two City of Toronto projects that were already at the end of design, so that we could have some real back and forth with the design team and help educate the design team, but also help them educate us in terms of what's possible to change at later stages of design and how drastically we could reduce emissions while not having a big change on the design or the construction process. So that was kind of two real projects that we kind of tested that out with. We also had education and engagement with industry. So we had 4 separate workshops that we held with different types of stakeholders, which I'll talk about a little bit later. And then finally, we created both recommendations for the Toronto-specific recommendations for the TGS, the Toronto Green Standard, and also more broad-based recommendations for the province as a whole, or for municipal governments across the province more correctly. So I'll touch on each of these a little bit in this presentation. I won't get into tons of detail on all of this because obviously we only have an hour, and I want to save some room for question and answer at the end, but happy to chat with anyone after to dig into anything that they would want to follow up on. So just quickly to give you set up the stage on how we started the project off, we did actually, I don't have a slide on this, but I'll mention we did have an expert project advisory committee of about, I think it was about 15 folks, experts in industry, from developers to manufacturers to designers, engineers, architects. So we did all of this process was all guided through the input of that advisory committee. So it was not just like a few of us in a silo making these decisions. All of the key decisions were discussed and tweaked based on the great expert input from the advisory committee. So thanks to anyone on the committee that might be listening to this. So the first survey that we basically did was we went out and sent this widely across our networks and asked anyone involved in life cycle assessment or embodied carbon assessments to provide information to us about what is their familiarity with LCA and embodied carbon, what barriers they may face, what they typically, how they would typically do the assessment. So what kind of what scopes of life cycle phase they would include, what part of the buildings they would include. Are they only looking at core and shell and envelope structure, or are they including other things like mechanical finishes? So we had a whole bunch of questions in that vein to really just get an understanding of how and why and people are doing these assessments in Ontario. The key takeaways from that survey are listed here. So basically, some of the key takeaways was that this is already being done. We had a few dozen respondents saying that they're doing this on a few, they've already done this on a few projects. So this is not, a one or two projects in Ontario that have been doing this. It is starting to roll out through the industry, which was a important takeaway, because there was a question mark about, is this really how common are these assessments? And we found that there was, dozens of professionals doing multiple projects each, and those are just the people that responded to us. So we assume there's probably more out there that didn't respond to us as well. Some of the key takeaways that we're getting, basically, and instead of reading through all of these, the summary on all of these are basically, there's a wide range in how people are doing this, right? There's different data sources people are using, from manufacturer specific EPDs to Canada-wide or North America-wide EPDs, or even European data. There's a range of what life cycle phases people are included. Some people are just looking at upfront carbon, some are looking at cradle to grave, some might be looking at including the D, end of life. So a lot of inconsistencies, or a lot of variation in how these assessments are being done. And probably our number one takeaway would be that all needs to get firmed up, and people need to start, doing these in the same way, so that we can compare one result to another result for different buildings, for example. Because if one person is doing a totally different, doing their assessment in a totally different way with different boundaries and different types of data, it's really not a high quality comparison then to do that, to compare those numbers against another project that's very doing it a very different way. And one of the main takeaways, or one of the common barriers, point 6 here, was just that most people just weren't sure where to begin, how to integrate this into their practice and into their processes. So that was one of the key takeaways, that we need to do a better job through things like the CLF Toronto and other government initiatives to help people understand how exactly you apply whole building LCA into a typical construction project. So survey 2 was around actual data. So actually asking people to provide us with the results of some of the studies that they've done in the past, so that we could start doing this benchmarking. We asked for the results to be broken down at the minimum granularity that they had available. So ideally, each life cycle phase would have a separate carbon, embodied carbon amount. A1 to A3 would have a separate one from A4 or A5 or any of the B or C stages. In some cases that was possible, in some cases it wasn't, right? Some people only had a final result. So it depended on the software that they were using, how they did the assessments. We also asked for information such as, building area, occupants, stories, use, location. What was the primary structural system? So is this a, primarily concrete, reinforced concrete building? Is it a steel structure building? Is it a mass timber building? And then we asked how they treated carbon sequestration. So we ended up getting 41 project results back. And I do have to preface this, and we try to always remember to say this, that these are self-reported results. So we didn't have the time or our ability or our resources to go through each of the studies and make sure that they had the same boundaries and make sure that they had the same type of data using. And in fact, we're certain that they didn't have all the same boundaries and data types and data sources. So there's a lot of noise in the results, I guess is what we're saying, but we still think it is valuable to look at this and understand the range that is currently being reported in the industry. So always, all of this data should be seen with that caveat. This is all self-reported, and all the assessments were done in slightly different ways. But given that caveat, the results were quite interesting. One of the things we did was compare different tools. So The total average for the embodied carbon cradle to grave was around 405, and these, sorry, the units aren't on this slide, but it's kilograms of CO2 per meter squared. So this is the intensity values. And we found that when we broke it out by the two most common tools, One-Click LCA and Athena, the results were, not hugely different. Again, they're different, but some people may have been concerned that one tool is twice the values of another, or something like that. And we saw here that the results were relatively consistent between these tools, given our data set and given the caveats that I mentioned before. Another interesting finding here was that the non-timber structures, so concrete and steel, they have higher embodied carbon typically than the timber-based structures. We only did have one fully steel structures building, so that's obviously a very small sample set, but generally speaking, the embodied carbon of those non-timber structures were quite a bit higher. You can see in the middle column here. When biogenic carbon is taken into account, so that's the carbon stored in the wood itself, the difference is significantly larger, but there's a lot of debate right now in the industry about how to account for biogenic carbon and whether it's appropriate or not to include that in our calculations, because we're not really sure what will happen to that carbon at the end of life of the building. The wood could, the wood could be incinerated, it could be burned, and the carbon goes back into the atmosphere, or it could rot in a landfill, and to some extent that could go back into the atmosphere. So the current general practice is to not subtract biogenic carbon from the embodied carbon values, but just to show the numbers alongside. But you can see here that typically the biogenic carbon in these timber-based structures, the carbon that is stored out of the atmosphere and locked into the building over the course of the life of the structure, is around half of the total embodied carbon footprint of the project. So some interesting takeaways there. And when we put all these numbers, all the numbers that we got into our Excel and sorted them by different building types, this is what we got. So the first column, maybe I should just explain, is you can see it says 503 buildings, and this was Part 9 residential buildings. So this was the results of the other study that was done by Chris Magwood, that we just included in our benchmarking, so that people could see this all in the same spot. But that first column wasn't from our study. Those results are from smaller, typically single-family homes that are stick frame construction, so not mass timber. They are timber-based, but they're not mass timber. They're typical traditional stick frame type construction that you would see in any subdivision across the country driving around. And the other three columns are the results from our study. So this is broken up into large residential buildings, commercial office / retail, and then all other building types. These are the categories that the City of Toronto uses, so that's why we broke them into these categories. And you can see here that there's quite a range. Obviously, it's one of the key things to see here. We've got some outliers up near 900, and we've got other really low values down in the 200s. The mean and the mediums are pretty much, more or less consistent around the, mid 400 range, I would say, or low 400 range. So this was a really important takeaway, just to see the range that the industry is calculating here. And again, there is noise in here, so that if everyone were to do this the same way, we think these would have obviously tightened up a bit. These bands would be a little bit more consistent, but we think that given the relatively high number of sample points, 41 buildings across Ontario, we think that these mean and median numbers are pretty good values that we can make some policy based around. I see there are some questions coming in. I'm not actively monitoring the chat, but maybe Michael, if you want to just monitor that and jump in if you think it's relevant to talk about as I go, I'm happy to do that. Or if not, if I don't hear anyone interrupting me, I'll just keep plowing through and we can have a discussion at the end. So another result here was that when we looked at the life cycle phases, we saw, which we've heard and we've seen this in other studies, but to look at it and see it in Ontario specific context is useful to see that the vast majority of these emissions are happening up front. So in the A phase, A1 to A3 is the material production and making the materials. A4 is transportation to the construction site, and then A5 is the actual construction process themselves or itself. So there is some question about how accurate the A4 and A5 data is. This needs to be improved over time, but this is what is being currently presented, and we can see based on the current data and the current tools, we're seeing a vast majority at A3 and then a little bit more A4 and A5. So one of our recommendations that I'll talk about more at the end is that we're recommending to kind of start with smaller scopes and more simplified scopes so that people can firm up their processes and data and get better numbers. So we're recommending future policy to start with just the upfront carbon of the A1 to A5, because it is all happening, now in procurement. It's not happening in 20 or 30 years down the road, which B and C and D would happen even longer down the road for C and D. This is the emissions we can really control now, and it is the vast majority of the emissions. So we're really suggesting folks focus on A1 to A5 going forward. We've also broke down the results based on where it happened, where the emissions live in the building, for lack of a better term, what parts of the building are responsible for this. So we can see walls, which includes the envelope is, the number one culprit there, and then we've got floors, beams, and columns, and then foundation. So not surprising here. It's mostly all of the main structural elements, and again, some of these studies are only limited to structure and envelope. So if they were to include finishes and other things, then these numbers would probably change a little bit. But again, based on current reporting, this is what we're seeing. So these are the kind of takeaways from that survey too. Let's see, anyone I want to highlight. Well, yeah, one was that the intensities increased with building height. We found that typically taller buildings had a larger intensity value, not just a larger value, which obviously makes sense, but the per unit area is actually higher. And this is because there's typically more foundations and more high strength materials are required for these larger buildings. So ultra high buildings seem to be more carbon intensive than on an intensity basis than mid-rise, for example, or low rise. Anything else I didn't mention? Yeah, and again, the last one I think is probably the most important, that we really want to get consistency in how these are done going forward, so we can firm up these numbers in the future. All future policies should provide clear guidance for required life cycle phases, objective assessment, and material quantity data, and how to treat carbon sequestration. And then just quickly to show you, this is the list of the 41 projects that we use. So it's a range of different developers and different building types across Ontario. So we really thank all of these teams and all of the organizations involved with providing this data. So that was kind of what we found from our surveys. Wanted to jump into the two city-owned projects that we worked with. These are the two of them. One on the top there is the Western North York Community Center. This one is actually a steel frame structure, and the reason that they made that decision was they said that mass timber spans didn't really work with the dimensions of the site, but they found that they had the most flexibility with the site and the spans that they wanted with steel. So that was kind of an interesting finding, that sometimes the material choices can even be constrained by just the dimensions of the site and what a efficient or optimized span for those different materials might be. The second project here on the bottom right is the emergency medical station. It's a new headquarters for Toronto Paramedic Service, and it's a really interesting building that's going to be all mostly mass timber. So we had some really interesting conversations with both of these design teams about what they did, why they made the decisions they did, and then help provide some additional recommendations on some material substitutions that they might be able to make. The Western North York Community Center, we found that their cradle to grave embodied carbon calculation came out to be about 485 kilograms of CO2 per meter squared. So just a little bit above the means and medians we were seeing in our benchmarking. And the biogenic was around 82 kilograms of CO2 per meter squared. Unfortunately, there weren't many opportunities for revising the materials on this project for a number of reasons, but they basically they really learned a lot from the process of calculating the embodied carbon and have ideas for future projects. But unfortunately, this one didn't make any, I believe they weren't able to make any changes, but they weren't able to commit to any changes at this time, I think, but they're under investigation for if it's possible in the next few months to make any. And just for an example of the type of recommendation or suggestions that we made, you can see here, they are using this XPS installation on the project, and we were able to propose other similar types of materials that have significant reduction in the embodied carbon. So this different new generation formulation for XPS that has a lower impact blowing agent has about a 63% reduction based on our calculations for the insulation impacts. And there was another option that we found called a Glapor, which is 73%. Other things that we recommended was, just looking at suppliers. For example, they had some walls that were made of terracotta tiling, and we just kind of provided them some numbers about different suppliers. If we were to find one from somewhere close by in the eastern U.S. Versus someone, a supplier in Portugal, and what the 6 tons versus 40 tons of CO2. So some significant emissions there just by where we're shipping our materials from. The other project we were able to they were more had more flexibility in making a couple changes just based on where the project design was, and they were able to implement a couple of the changes we made. So we found this was already a very low carbon building because of some of the reasons I mentioned before, like being mass timber. But so we found pre changes that we suggested, the number was around 380 kilograms of CO2 per meter squared. So quite a bit below the means and medians we were seeing. But after just making, I think it was 5 or 6 material substitutions, we were able to bring that down by about 30% to 280. So this was now reaching the very low end of the benchmarking results we saw. So that was a really great result. And this graphic just shows all of the materials in the life cycle assessment in gray, and then the ones that the big ones that we focused on trying to find substitutions for that are in the brighter colors there. And this is the result of those reductions. So you can see the specific recommendations in the green waterfall part of the graph here. We have lower impact XPS insulation was a big reduction, and as well as lower carbon concrete using GUL, which is the limestone cement, Portland limestone cement, and a higher percentage of SCMs. And then another interesting one that hadn't come up on previous projects was a low impact concrete slab sealer. So this building, as I said, it's a ambulance storage facility. So they have a very large slab on grade, which required a lot of a high volume or a high amount of sealant on the concrete slab, and that sealant that they were planning on using had quite a high global warming potential because it was quite a volatile chemical. So we did some research and were able to find that there was another, a different alternative product on the market that did pretty much the same thing, but had a significantly lower volatility and lower global warming potential, and it actually had a quite significant embodied carbon saving on something as simple as a concrete sealant. So that was a really interesting finding. So yeah, these findings basically showed an 800-ton reduction in embodied carbon, and the project team was really surprised and happy to learn about all this stuff. So they kind of went right ahead and said, let's make these changes, and let's because nothing had been ordered yet. We were still at end of design, but before tender. So they're making these updates in the design documents right now. And they are going to try to start making these their go-to selections for future projects as well. So some are already really impactful results that came out of this study and the engagement with the city projects, which we're really happy about. We also did an assessment on the photovoltaic system on the building, which we thought, because this was something we've heard a lot of people talk about, whether the carbon investment in adding more materials like solar panels, whether that pays off over time or how, how long it takes for it to pay off. So just to walk you through this image a little bit, the gray, horizontal gray line here, that's the total embodied carbon of the building that we calculated before the optimization, before the material substitutions. And if we were to account for the operational energy and carbon that is emitted every year from heating and cooling and ventilating the building, that's this kind of gray line that steps up over time. So we calculated that by 2050, this point here would be the total whole life carbon of the building. Sorry, whole life carbon of the building over 28 years without any PV. So that was option one. And then option two was if we add the solar panels, and we calculated it's a pretty significant jump in embodied carbon, but when we can account for the carbon that it offsets by feeding back into the grid, the total carbon footprint of the building actually is reducing over time every year based on those solar panels. And even when it's replaced in 20 years, when the panels are replaced in 20 years, you can still see that after the reduction for the second replacement, we're down up to about here. So I think it was about a 30%, 36% it says in the title here, 36% reduction between those 2 points. So this was another really interesting finding that we hadn't seen results or studies like this on Ontario-specific mass timber projects. So this was a little bit of a unique situation, and we found that it was indeed a good carbon decision to install these PV panels.
Sorry, Ryan, just quick question for this slide. There's a question about the source for the PV emissions data.
Yeah, so the PV, I don't remember the specific EPD that we used, but it was a manufacturer specific EPD that we had for, I think it was like, I don't know if it was the same, I don't think it was the same manufacturer, but it was the same type of a system. It wasn't just like a generic PV or a different something that wasn't applicable. So we can find that out for you, but I don't have it at the top of my head. But it was a specific PV panel that was appropriate to use here.
Sounds good. Thank you.
No problem. So in terms of the workshops, we did have 4 separate workshops. And again, great thanks to TAF for kind of pushing us on this. If anyone's that's involved with TAF grants, they kind of ask for a few tweaks or additions or suggestions on moving forward. And one of the things that, we had said we would do a workshop or 2 workshops, but they suggested separate workshops for different stakeholder groups, which we thought was really interesting. We hadn't thought about that before, but to have a different discussion with the designers versus the material manufacturers. Workshop 3 was with developers, and then workshop 4 was with governments. So it's quite interesting that the conversations were varied between these, obviously, different concerns and different points of view. So it was an interesting approach. And these all are posted on YouTube. Unfortunately, we didn't think it was appropriate to post the discussion because we wanted people to be able to talk freely. So I think the YouTube videos that we posted are just kind of the intro part of the session. So those are a little bit more consistent between them. It was really the discussion part that was unique between the discussions, and that part we didn't think it was appropriate to share. So unfortunately, you can't hear the discussions, but we do have key findings and some of the key takeaways from those meetings in the primer report in one of the appendices if anyone wants to dig into that. But between all of these, we had, between the people attending the workshops and the YouTube viewers, I went back and checked the numbers when we did our final report to TAF, and we have almost 1,000 unique people that engaged in these workshops. So quite a broad spectrum of the Ontario and maybe beyond Ontario, but the stakeholders in this industry. So we were really happy about the outreach we had there. And in terms of the next step, we have made some specific recommendations for the Toronto Green Standard. So anyone that is familiar with the Toronto Green Standard, it's required for for large project construction in Toronto. It's not required for single family homes, but for larger projects it is. Version 4 was just released in May of this year, a few months ago, and it is the first version 4, to have any requirements around embodied carbon. and I'll touch on those in a little bit further, but just to finish on this slide to say that council is considering updates to version 4 in next year. So there is a plan to have a version 5 come out in 2015 and a version 6 come out in 2018. And this is how the tiers work, that, you know, whatever tier, so tier 1 is mandatory right now. Everyone has to do tier 1, and tier 2 is optional if you want to go above and beyond and be subject to more stringent requirements. And if you hit that tier 2, you get a development charge refund, a monetary incentive. But in the next version of the TGS, the optional tier 2 will become the mandatory tier 1. So it's an increasingly popular approach where, you know, we're showing industry or they're telling industry these are the requirements they're going to be subject to in the future. So, you know, plan for that, get used to that, it's coming. And then in a few years, we ratchet it up to that next level that had been previously published so that people know what's coming. So this is the plan for updates to version 5 and version 6. But as I said, council is considering just updates to version 4 next year. So these recommendations that we're sending may be implemented next year as part of version 4, a revised version 4 before version 5 comes out. So there are 3 different versions of the green building standard: the low-rise residential, mid to high-rise residential, and city and agency. So that's the city-owned projects. So the 2 examples that we had looked at previously, the Western North York and the EMS emergency medical station, both of those are city-owned projects, so they're subject to those requirements. I think I already talked about that. So yeah, these are the current embodied carbon requirements in version 4. So it's only part of the city. It's only required for city-owned buildings. For the non-city owned buildings, it's a tier 2. So it's not a requirement for people that are going for tier 1 in version 4. Sorry, there's a lot of numbers there, but it's only required for the optional tier 2 if you're not a city project. But that requirement is just to do an assessment, right? Just to calculate and report your embodied carbon. It doesn't have anything, there's no minimum number, and there's no, you know, reduction. It's just to report to calculate and report. So that's a disclosure. It's limited to the structure and the envelope. And they say to follow the Canada Green Building Council's zero carbon building standard methodology. And that methodology follows the LEED methodology. So it's basically the same. This is aligned with CAGBC and LEED. And then for tier 3, which is again like the second optional level, there is a reduction requirement on this. It's a 20% reduction on embodied carbon. There is a separate requirement for in the separate standard for smaller construction, small buildings. And again, there's no tier 1 there, but the tier 2 is to use a different tool called the BEAM tool, which was developed by the Endeavour Centre and Sustainable Buildings Canada, specifically for low-rise construction. And they have a specific intensity that they're targeting as 250 kilograms of CO2 per meter squared. So that is just in the higher part of the benchmarking that we saw for that type of building. And just to point out the specific wording in the standards here. So this is the mid to high rise residential and non-residential new development. So this is high rise and it's not owned by the city. This is that standard. And you can just see here that it's tier 2 and tier 3 requirements here. There's nothing listed for tier 1 currently. But just to point out that there is this note at the bottom here, which says the City of Toronto is involved in 2 studies to benchmark the embodied carbon in new construction. The results of these studies will refine and replace the targets above to ensure the performance measures can best be implemented in the Toronto context. So this note is in reference to the study that I'm presenting right now, and also to that other Part 9 smaller building study. So that, just for anyone that might have been wondering about why updates to version 4 could be considered by council, is because this note is in the current standard. So it already kind of has a warning, if you will, that these are kind of temporary requirements, because they knew that these studies were coming when they drafted this and didn't want to preempt the study results. So they kind of put in a placeholder requirements now with a note that these might be updated. So here are the 2 specific studies. so the one on the bottom there is the one I'm talking about right now, but the one on the top is the lower rise residential construction project. The report is called the Emissions of Materials Benchmark Assessment for Residential Construction, excuse me, or EMBARC is the acronym that they're using. So if you just Google EMBARC embodied study, it should pop up. But lots of great information in there. Don't have time to go through that study as well, but I recommend you guys to check it out if you're interested. And now I'll just quickly go over this primer. I know we're running out of time and I want to save time for the discussion, so I'm not going to go into this into detail. I'll just kind of orient you. It was released just this week. It's up on the Mantle Developments website. If you go to our website, go to publications, it's the first thing right there. And we've broken it out into a part 1 where it's a little bit of an introduction to embodied carbon and what our recommendations are for the for municipalities. And then part 2 goes into a little bit more of the details of what a consistent methodology would look like that we're recommending. So probably doesn't make sense for me to go through all of these points. Yeah, I guess the point is here, we're just walking people through the thinking here, right? Like saying this is a growing and significant source of emissions in Ontario. And the point is, again, is for people who are reading this, a lot of the people who are reading this might not have ever known about embodied carbon. So we give a bit of that intro for policymakers and municipalities across Ontario that might not know this issue. But, you know, these are important, they're growing, they're not regulated. The vast majority of these emissions are from a few handful of materials, you know, like everyone on this call probably knows: concrete, steel, insulation, timber. There's a lot of low-hanging fruit that can be done. We heard in our workshops people saying, you know, some of the biggest construction teams in Ontario and Canada telling us like 30% reduction is no problem when this is prioritized without impacting schedule or costs. So, you know, that's a really key finding for people to know. This getting serious on embodied carbon doesn't mean you're going to double the cost of your project, doesn't mean you're going to have, you know, delays. It's just something that people aren't really prioritizing. And when you do prioritize it, people are, you know, we were told by multiple people that, you know, 20 to 30% reduction shouldn't be a problem, shouldn't impact cost or schedule. So, you know, that's a key finding for people to be aware of. Future policy needs to be consistent, as we said, the methodology, so we can compare results. Benchmarking has been done, right? This is another concern people say, like, we don't know what number makes sense. Well, you know, there has been benchmarking. We can use that and make appropriate policy around it. And then some suggestions on how to roll this out. So maybe start with disclosure and reporting only, as Toronto did. Maybe next you want to set a limit or a cap and you show the reduction pathway over time. Different benchmarks might be appropriate for different building types. As we saw, you know, low-rise construction has significantly less embodied carbon. So we might want to be cognizant of the type of building we're talking about when we set these requirements. But in general, around 500 kilograms of CO2 seems like should be easily achievable for large construction. And it's, you know, we're getting a little bit of flack on that number because people are saying that's too high, but we were trying to balance the, you know, not trying to scare everyone in the industry and making it reasonable, not having everyone to change everything that they're doing, making, you know, reducing pushback, but having it reduce over time. That's the most important thing. So that number probably could be lower, but that's what some other international examples are using 500. So we're saying around 500 seems reasonable. And then over time, better tools will become available. And we should change this, you know, we should firm these caps up and reduce them even faster when we get better data and show that people are actually meeting these caps very easily without, you know, making any drastic changes. We also give some thought around different classes: Class A, Class D, Class C, Class B, Class A life cycle assessments. We're, you know, borrowing the language of cost assessments, which people are familiar with. So we can have different types of LCAs, different classes at different times within the project life cycle, and they would actually tell us different things, and we can make different decisions based on those. So we've got some slides on that. And then I guess the last one is important to say that we recommend a standard reporting template, because when everyone's doing this slightly differently, they're all reporting everything slightly differently, and it's very hard to make, you know, high quality comparisons when that's the case. So we provide in an appendix in this primer a recommended reporting template that's based on the Canada Green Building Council, but there's some tweaks to it which I can quickly touch on. So This image is similar to the one I showed before, which was just the benchmarking, but this one we have caps superimposed on top of them, recommended caps. And again, this is just the study authors. This is not an official City of Toronto, position or anything like that. So this is all just put out there for industry to look at and consider, and hopefully some municipalities might adopt these caps or even more aggressive caps, but this is just the study authors' recommendations. So we are saying 500 for large residential. Again, this is kilograms of CO2 per meter squared. And you can see that we show a reduction timeline over the next few years, so that these caps are lowered, so that in 2030, they are half of the value that they would start at. And that's kind of what the best climate science is telling us, is that we need to half our emissions by 2030. So that's what we're trying to accomplish with these caps in this recommendation. Won't go into all these, but just to let you know that they're in the primer, we have a page, table 2 here, of design strategies. So this was really interesting feedback from the architects that we dealt with, and Kelly Doran's team at U of T. I'm an engineer, so I look at more of the structural side of things, the materials, in terms of like how they're made, where they're made, but Kelly and the architects came at it from a different point of view about like how the materials are used and how they're put together and the form of the building. So there's a lot of interesting findings here that I don't think we'll have the time to go through. One maybe quick one I'll just point out is transfer structures. I never thought of before, but when we have residential building, a residential grid layout for all of the units in a building, and then we've got the parking, underground parking, and those have different orientations or different dimensions of the units, right? The residential units versus this parking bays. So there's typically a huge transfer structure in the middle where because all the loads can't go straight down, they need to be put through this transfer structure. But typically those transfer structures are massive beds of concrete that can be multiple feet thick, and that's a huge carbon footprint that's just not required if we were a little bit more thoughtful in how we're designing the layouts, or maybe if we're able to get rid of parking or put parking somewhere else. So that's just a simple example of like design thinking that can actually, in terms of like the form and the space and the dimensions, that can actually have a huge impact on the embodied carbon. We have another set of strategies for material specific ones. These are the ones that the world I typically live in, and like what to change about our procurement of concrete or our steel, our wood, or our insulation. So a bunch of recommendations in there for folks to check out. This is the life cycle stages, and this is based on the National Research Council. Canada's NRC released a national guideline on doing LCAs, but they recommended, they have the blue dotted line, which is basically cradle to grave is what they're saying to include. And we don't disagree with that. That's the most correct, but we think it probably makes sense, as I said before, to start with a little bit of a simplified initial scope, and maybe in a few years when people are more familiar with this, we have better data, we have better tools, maybe then it makes sense to expand it out. But because these upfront emissions, we saw it's 90% of the impacts, 90% of the carbon lives up front. These are the things that happen now. These are the things we can directly impact by our procurement decisions. We really think there's a lot of value in focusing, just getting a little bit more laser focus on that upfront emission. So we're recommending in the policy primer to just focus on A1 to A5 to start. And then this is the object of assessment, how we broke this up. So in LEED and in CAGBC, they say just use the structure in the envelope. So we just give a little bit more, we break that down a little bit more. And we call that our simplified scope of assessment. And then we named this, if you want to add more to it, then we're going to call that the expanded scope of assessment. Because some people, some clients, they say, we don't want to just do the simplified. We want our full carbon impact. So let's include all the systems. So we're recommending that people always report the simplified. And if they do want to expand that, then report that as a second number, right? So that people can at least use that simplified number as a benchmark that we can all compare against. If everyone's using the same set of systems and materials, we can compare against that. Again, I'm running out of time. I want to have 10 minutes for discussion. So we're just going to flip through the end of these. Some recommendations about when you would do a Class D, Class C, Class B, Class A assessment, and what you might be able to change based on that, ranging from, number of underground parking spaces or main structural materials up at Class D to things like, salvage material or low carbon mixes as we get more advanced in the design. And then here's just some pictures of the suggested reporting template. So you can see, I know it's really small here, but we're asking for results per life cycle phase where that's where that's available. And then we have different columns for both simplified scope and then expanded scope if people want to do that. That would be those columns are optional. And we ask for both the absolute and the intensity value. And we're saying that the total intensity of the upfront emissions of the simplified scope, that's the thing that needs to be below the cap that we're suggesting. So, just because all the results we saw did this differently, some people were just giving absolute, some people were just giving intensity, some people, we weren't sure what scope was included. So we think having this kind of a breakdown would be useful going forward, or something similar to this at least. So that was a lot of talking. Hopefully you guys learned a few things and found that interesting and useful. But yeah, I'd be happy to open it up for discussion now.
Awesome. Thanks, Ryan. That was a great presentation. There's a number of questions in the chat, so maybe we'll start from the top. But of course, if we don't get through all of them, Ryan's email is up on the screen now, and you can also email CLF Toronto directly with any follow-ups that you'd like. So Samantha from EQ asked if there was any analysis done on the quality of data you received and whether or not it seemed consistent.
Unfortunately not. No, that was something that, I think we're pretty sure it's not 100% consistent. We know there's noise in these results, so that's definitely something to be aware of. Yeah.
Great, thank you. The next question was from David, and actually, David, if you want to say it yourself, so I don't paraphrase, because I think it was about a specific topic on the screen.
Hi, Dave.
Hey, how you doing?
Good, thanks.
Good. I'm just trying to understand whether or not there's any thought regarding whether or not existing buildings, when they do renewals, if anybody is thinking about it, or if this is all, everything you're doing, everything you've analyzed is all new construction work.
Yeah, great question. So this is for new construction. We do say that any renovations should consider the embodied carbon on any new materials that they procure, but those caps wouldn't be applicable to a renovation, because this is assuming that all of the foundations and all of the structure and all the envelope is all going to be brought in and is new. I will say that the CAGBC, for example, and we've changed the requirement now. In the past, it just said to do a life cycle assessment on if you want to get the certification. Now it says a life cycle assessment on any new materials that is part of the current project. So if you're doing a renovation, you would only need to include the LCA on any new materials. And yeah, these caps would not be applicable to that. They'd only be applicable to new construction.
Thank you.
You're welcome.
All right, our next question is from Matt, and I'm going to summarize it. So the question is around whether we're looking at the existing site's use to factor in the carbon accounting from a sequestration perspective. So when we think about a low-rise wood frame house that has a lower carbon use intensity today, it's actually converting land that was able to sequester carbon before it was built versus more urban high-rise buildings, which may be on land with limited ability to sequester carbon.
Yeah, this is a really great point, and it's definitely something that there needs to be more investigation on. We do have a section in the report that says areas for further study, and I'm pretty sure this is listed there as like land use impacts on this. So it's a great point. I don't really have any answer for that, other than to say you're right to bring this up, and it's something that we always do need to consider, is not just the building itself, but the site and the land and how our decisions are impacting all of those interactions between them. So yeah, thanks for bringing it up.
All right, another question from Anna. Was there any material or components that you found were not typically included in the assessments but should be?
Oh, that's a good question. Nothing is coming to mind. I think most people are following the Canada Green Building Council /LEED requirement about just looking at the structure and envelope. So but I think maybe the insulation is one thing that probably a few people were missing, because I think when some people think of envelope, they think of like cladding and maybe not the layers of the envelope. So that's something. And then also, if you read the fine details of the CAGBC and LEED, they also ask for all finishes on structural elements, but not vertical finishes on structural elements. So if we're talking about columns or shear walls, it would be all the finishes on that up to the insulation and even paint. But if it's an interior partition that's not structural, then we don't include any of that. So that's the thing that I think some people don't quite catch that. So it's the whole envelope, including the insulation, including the finish, if it's a structural wall, and then all structural walls, all the finishes on that. And again, that's one of those things that some people might want to include in partitions because they do all of their walls, but anything that's not structural should be part of that expanded scope. And that's where these comparisons get difficult, because if some people are including like interior partitions in their numbers, but other people aren't, then it's not really a fair apples to apples comparison, because it's different. We're including different systems in the building. So as I said, there is noise in these numbers. That's just the reality, but we didn't think that noise should be a reason to not do this type of assessment. We still think this assessment is needed so that we can get better and improve and get more consistent in the future.
Awesome. The next question is regarding TGS version 4. So it currently references the CAGBC Zero Carbon Building Standard version 2. Wondering if there's any insight on when this will shift to version 3.
Yes. That's a good point. And I believe that they would be updating that next year when they do any updates to version 4. But I mean, you say in your comment there that version 4 includes caps or reductions, which is correct. But I think that's the main change in version 3, and that wouldn't be applicable here to the Toronto Green Standard, because they're saying just use that methodology, not the cap. So I don't think changing to version 3 of the CAGBC standard would really make a big difference, but it's probably something that they'll do when they refresh the standard.
All right, another question from Zaina, asking what insight can you provide on embodied carbon reduction efforts happening on manufacturing side to look forward to?
So I don't have too much insight into that actually in Ontario. I know I'm hopefully most people on this call are aware that we just got a really great new data point from manufacturers. The Ontario Concrete Ontario released a industry average concrete EPD for Ontario, which is really useful for anyone doing LCA assessments in Ontario. We made sure that One-Click LCA, which is the tool provider we use, had uploaded that to their system. So anyone that uses One-Click LCA now, you can use that those EPD values. But I know just from from following media, that a number of the steel mills in Ontario and in Hamilton are also looking to upgrade their fuel source for how they make their steel. They're not actually, if my understanding is correctly, they're not actually changing from like blast furnace to electric arc furnace in some cases, but they're changing the fuel that they would feed into the blast furnace to be clean hydrogen, I believe. So all that to say, there are significant changes being made to decarbonize our manufacturers, but I don't have tons of insight into any more specifics other than that.
All right, two kind of similar questions from Rami and Taryn. So Rami's wondering about defining GFA going forward, and if we're following the NRC's definition, and if that definition had been applied consistently in surveyed projects. Yeah,
that's a great question. So we do comment on that a few times throughout the primer. There's some like call out boxes on GFA and how to use that. So the quick answer is there is inconsistency in this. The CAGBC right now follows ASHRAE, which is based on energy modeling, and the National Research Council follows this quantity and surveyors approach, which is more based on materials. So I mean, they both have arguments as to why it makes sense. CAGBC doesn't want to like throw in multiple different types of area measurements, because people that are following the Zero Carbon Building Standard or LEED clearly need the energy-based metrics as well, but we are recommending to follow the National Research Council, the quantity surveyors approach. And the biggest difference between those two approaches is that the quantity surveyors says to include parking areas in your area number, whereas the ASHRAE folks say you do not include parking areas in your area number. So that's quite interesting, because if a project has significant parking, you know, that's like you could have a 30% difference in your denominator, in your area number, when you're doing your intensity value, right? Your total GDP. Most people would include the parking structure in their GWP values, but almost all people, if they're following CGBC, aren't including the parking area in their area number that they divide the GDP by. So that has a very different impact on your results. So that was definitely one of the things that we listed for, you know, future collaboration, and we need to get on the same page on this as an industry. But our recommendation is to follow the NRC and to include parking in both your GWP and your area numbers.
Awesome, thanks, Ryan. I think we're just at time now, so we can call it there. Sorry to anyone we didn't get questions to. You can email Ryan or CLF Toronto directly. Otherwise, visit our website, stay in touch. We're going to have another event coming up in about a month. So yeah, look out for that.
And please, and thank you, Michael, and thanks everyone, and share this report widely. It was 14 months of work, so I don't want it to just sit on our website as a hot link. I want it to be sent it to your representatives. Hopefully we can get some new policy in Ontario made based on this.
Absolutely. Thank you, Ryan, and thanks everyone for joining.
Thanks. Bye-bye.